Hello, everybody, and welcome to this GraalVM Cloud Native Application and Micronaut deep dive. My name is Graeme Rocher. I am an architect at Oracle Labs. I have been working there since 2020. I may have heard of something called Grails historically. I created that and worked on that for a while. And Micronaut is more or less the successor. You can connect with me on social at those links if you fancy it afterwards. So on the agenda for today, we are going to do an introduction to Micronaut framework for those who don't know what it is or haven't heard of it or anything. We will do why you would choose Micronaut. Go over a demo and overview of like Micronaut fundamentals. And also look at the enhancements specifically for GraalVM and JDK21. Look at the improved performance, modularity, and then we'll go through the core updates in Micronaut 4. Things like the Jakarta migration, the dependency injection improvements to generic handling, the expression language stuff, bean mappers, all the enhancements that you can expect in Micronaut 4. We'll look at the web tier. What we've done there with virtual threads, with HTTP3, with IO Uring, the new client-server filters API, Micronaut serialization, the control panel, context propagation, and so on. And we will look at data and cloud. So what updates in Micronaut 4 for Micronaut data, the work we've done on open API generation, around Testcontainers, the cloud module updates, and also go over an overview of GraalVM Cloud Native. Okay, so let's get started. So where this came about, right? So Java has a number of challenges for framework developers like myself, right? Where a heavy burden is placed on the framework to kind of work out how the application functions, right? So there's a limited annotation API that doesn't really model things like meta annotation. So you have like an annotation on an annotation, or you need to scan for annotations, right? There's no like built-in way to do that in the JDK. So most frameworks have kind of rolled their own solution. And then reflective data structures are slow to initialize. They occupy a lot of caches. And of course, they have things like type erasure, which places a heavy burden on frameworks to kind of work out at runtime what to do. So when we looked at building Micronaut, the solution we came to was basically let's just like avoid reflection, right, and see what that looks like. So we built prototypes, and sure enough, we were able to reduce startup time, reduce memory consumption significantly. Which only thing is, architecturally, it's very different from the way traditional frameworks work, which are built around reflection. So if you can avoid reflection, it's a good thing. It's not that it's not that reflection is awful. It works in native image, but if you can do less of it, it leads to less memory consumption, faster startup, and so on. So with Micronaut, it's an open source Java framework, and it's focused on these modern architectures. It's a more complete application framework in that it's not just a library for building HTTP style applications. It's you can build any type of apps, and we have different runtimes for whether it be for command line apps, for serverless, for different kinds of applications. It's basically an annotation-based programming model, much like Spring is an annotation-based programming model. If you're familiar with Spring, it's a very, very familiar API. And it works very differently, however. So whilst Spring typically defers everything to runtime, all the analysis of how the application works, defers it to runtime and then uses reflection to figure it out, Micronaut works differently. It plugs in to the Java compiler, or we actually support 3 different languages, or the Groovy compiler or the Kotlin compiler, and pre-computes, how, for example, with dependency injection, how an object is wired together, and kind of indexes it to say this is like discoverable, at runtime, right? So it creates the index, the bean index, if you want to call it, during compilation phase. It creates a type that essentially knows how to wire the object together without having to work that out at runtime, without having to, like, if you think about how something like traditional reflection-based dependency injection systems work, whether it be Weld in CDI or whatever, they basically have to scan the class path, get hold of a class, and then get all the reflective data, find all the fields, all the methods, just to figure out the one field method, whatever, that has @inject on it, right? Or the one construct argument, right? And by building those indexes ahead of time, we just have a lot less work to do when the application is actually running. And that kind of translates into the weight of the runtime of Micronaut. So there's a client server based on Netty. I see I have a bug in my slides over there, where luckily we can debug my slides and fix things as we are working on it. But yeah, so I can make updates to these slides. But yeah, basically it should say on Netty. And the Netty itself runtime and the whole runtime infrastructure that requires to run Micronaut applications is much smaller, because traditional frameworks have significant infrastructure pieces to work with reflection. And you see that in any library that relies on reflection. So if you look at like Jackson Databind, for example, it's like 2.4 megabyte jar file, right? It's a lot of code to have around at runtime. When and much of that code is taken up by logic to essentially model a JSON object and its properties and cache that data so it's fast. Yeah. So if we can build those indexes at compilation time, they're significantly faster. So Micronaut has different solutions for these different problems. For the annotations, we pre-compute what we call annotation metadata. So for any type that's indexed, we pre-compute all the annotation information, including what annotations are annotated with what, and make that available without using reflection. In source code, you can often see in your source code, it's really convenient, right? When you define a list with generics, you can see that it's a list of, say, angle brackets string, right? So we know that's a list of string. But then when it gets to the execution part for a framework, suddenly type erasure kicks in, and that's not a list of string, it's just a list, right? And you have to perform all these runtime gymnastics with the reflection API to figure out that this field or this parameter on this method is a list of string, when we know it's a list of string, right? So Micronaut will also pre-compute all the kind of type information, so it's available to the framework in the points where it needs. And we eliminate reflection wherever we can, eliminate reflection data caches. There's no class path scanning at all. So there's no scanning of the class path, figuring out like what's annotated with what types are regarded as beans, what types are regarded as candidates for dependency injection. None of that happens. We have no dynamic class loading. So this is one of the things that's really nice about Micronaut is its simplicity, right? In a traditional application where you deploy to, say, Tomcat, there's very complex class loader hierarchies to support redeployment of the application at runtime. So, a servlet container will have a load your kind of code in its custom class loader. In order to be able to support unloading your code, it kind of creates all these class loaders and very complex class loader structures, which leads to hard to debug problems, right? There's no magic class loaders in Micronaut. It's all just the system class loader. So that makes the whole architecture much simpler, because there's nothing to worry about in terms of dynamic class loading. It's just very simple. So we made a bet on the future being intelligent compilers and smaller, leaner runtimes, and that's really what Micronaut is and what GraalVM is, right? A very smart compiler. So GraalVM is able to increase your throughput in JIT mode with its JIT compiler, but it's also able to build specialized native binaries or native executables, and specific for the machine that you're running on. And those specific executables are optimized for the hardware that you're running. So I'm running on a ARM machine here. It'll be optimized for this machine. And the result is significant efficiencies in terms of things like startup, memory consumption, and so forth. So Micronaut and GraalVM have had a long and very happy relationship in terms of the way they work together and work really well together, because GraalVM Native Image fully supports reflection, just to get that out of the way. But you do need to tell Native Image about where reflection is used. So if, for example, you have Jackson in your code base and you're serializing, deserializing an object to and from Jackson, to and from JSON, you need to tell GraalVM, hey, that's an object that's going to be reflectively accessed to serialize and deserialize it. Because Micronaut doesn't do any of that, you don't need to tell GraalVM anything. So the number of flags that you need to pass into the native image process to build an executable is significantly smaller compared to some other frameworks, right? Whilst a lot of frameworks generate a lot of essentially native image configuration or native image flags to configure the tool correctly, there's none of that. It just works. Yeah, the experience between the two, and on top of that relationship between Micronaut and GraalVM, we've been putting together a better set of best practices at Oracle Labs, where it's a curated set of modules that supported by Oracle, that are built at Oracle, and a kind of opinionated definition of how we believe cloud applications will be built in the future, multi-cloud applications, right? With GraalVM. So this is the kind of synergy of the two technologies in a kind of a more opinionated expression. So I'm going to do a quick demo of just getting started. So you can use whatever tooling or that you wish. Micronaut has fantastic support in IntelliJ Ultimate. I have here VS Code with our latest extensions installed. And what you can do is use the Micronaut panel to say, I'm going to create a new Micronaut project. And you can pick the version that you're after. I'm going to use the latest, the kind of application you want to create. The GraalVM you want to use, I'm going to use 21 because we're going to do the latest and greatest things. Name the application, package, which language you want to pick, which language you want to choose. You can add features and take away features, whatever. For the moment, I'm going to keep this demo simple. You can choose your build tool, your test framework, and just create the app. Open it in a new window. And here we are. Here we have the application. Set the active installation. Okay, so okay, so here I have a Micronaut application. It's very much like any other Java application in that it is it has a main method, an entry point, where you start the application, and it has a source main Java directory. I chose Gradle, but you could have chosen Maven or whatever else. It is when you create the project automatically, you get a test, and I'm actually going to change something up a bit here because using JDK 21, there is one caveat, which is that you need to use. So we also have a command line tool, right? So you need to use the build tool, which is Gradle Kotlin. All right. So I'm going to open that. Yeah. Right. Okay. Just wait for that to start up. Okay, so like any other Java project, you can run your tests with Gradle test. I think I'm having issues with the Wi-Fi. I'm going to turn it off. Yeah, that's my problem. Okay, so restart. Right, so let's just close that. Code demo. And hopefully that the Wi-Fi will allow me to configure my project this time. Okay, this looks more promising, right? Okay, so here you can see we have a test framework called Micronaut test. So you can annotate any JUnit 5 or Spock test with @Micronaut test, and that will allow you to dependency inject components. In this case, I'm injecting one of the components provided by the framework called embedded application. And you can inject that and work with it in your tests. So, I can run this test and it executes successfully. And, that's essentially Micronaut test. Now, you can either use @inject, which is essentially a Jakarta.inject JSR 330 annotation to inject components. Or you can come in here and you can inject the method parameters, which is also a nice way to do things if you don't want to pollute your class with fields and so forth. So the entry point for your app is here. Now there's various things that pop up here where you can run the main method, debug it, whatever. I really like continuous mode. So when you activate continuous mode, it'll start your application up and run it continuously, so it's running. And if I come in here to my app and I make any kind of change to starting up, whatever, every time I make a change, it'll bump the server and restart everything for me, which adds to the development experience, right? And is really nice. I have a build.gradle, but if you chose Maven, you would have a pom.xml. And we have a set of plugins for both Maven and Gradle that just make things a bit easier. There's an application plugin that just adds a few opinions about how you build apps. So instead of having to declare additional dependencies here, it declares them implicitly. And it adds a block where you can configure certain aspects of the way Micronaut works. Again, these plugins are completely optional. They just add to the user experience. So you can use Micronaut without plugins. It's just an annotation processor. But this says, I'm going to use Netty as a runtime, JUnit 5 to run my tests. And we'll get to those other things in a minute. So, how would you write an application or a simple app? Let's go ahead and write hello world. So what I'm going to do is come in here into my source packages, and I'm going to add a Java class. Let's new class. Let's call it hello controller, right? And let's add like import here. Hello, like so. And what I'm going to do is I'm going to inject a hypothetical hello service, right, to implement hello world. And clearly that hello service is not defined yet. I'm just going to create a constructor. Here we go. And I haven't actually implemented hello service yet, so let's create a class that implements that logic. So what I'm doing here is I'm using what's called constructor injection, right? So this is actually, I prefer this way more than annotating things with add inject. So what I can do here is come into add service and say this is a singleton. So effectively with Micronaut, when you want to make something, much like CDI or whatever else, or Spring, when you want to make something a bean, you have to tell Micronaut that it's a bean, right? So this is annotated with @singleton, and @singleton is a Jakarta.inject scope. So anything that has a meta scope becomes an injectable component, right? And that's effectively what I've done here. I've said I'm going to inject this. And what you can do is, write some kind of endpoint here that maybe, produces media text plane or whatever, and hello, like so. And we've implemented the endpoint, not yet. Let's call this dot hello service and say hello to whoever that is, right? And create the method in that object, which I can come over here and implement. And we've implemented like hello world, right? So there we go. So now we can test it out directly in this UI. So I can come in here and I can say, Fred, send the request. And there we go. My hello world is implemented, right? Right. So how do I test? How do I test this, right? So with Micronaut test, it makes it really, really simple because we have a declarative HTTP client. So you can say, I'm going to create a hello client. And I'm going to say that this is a client interface, and it's going to talk directly to my server here. So hello. You can even use the same more or less signature, right? Oopsie. So we can say I'm going to call hello there, except I'm going to consume it like so. And we can inject the client into my test here, like so. And we can say client dot hello Fred, and basically get a result back, right? Set equals something like hello Fred. Okay. Okay, so we can run this test like so. Let's try and run it in GraalVM test. Okay, so I have some errors. Can I find symbol client? Okay, so let's see, import. I think perhaps my lack of internet is holding me back here. Okay, let's try it. Okay. Right. Okay. Okay. Let's see. So set my JDK on the project. Let's go forward 1081. There we go. Okay. Right. And let's correct this. Code, like so. Import. Import. Seems I have some code messed up here. Okay. So let's write this test and set the result like so. Add an import set equals. Okay, so there we go. Now we have a test that's going to use my hello client to send a request and return a result and assert the result is correct. So let's run that. And the test works. So one of the things that is really nice with Micronaut is the speed at which you can actually run these kinds of integration tests. So I can have like thousands of tests that are actually making like HTTP calls, and they're full-on integration tests, and they execute very quickly. Yeah. So that's basically a small overview of like getting started. The quick way is Micronaut launch. You just go to start.micronaut.io, and there's a UI. You can even create apps via curl. There's integrated code wizards for IntelliJ Ultimate and VS Code. So if I come in here and I say new project in IntelliJ, for example, there is a whole Micronaut wizard that needs to be connected up to launch. But basically, there's quick ways to get started. We have integrated testing library support, and it works cross-test framework. So with Spock, JUnit 5, CoTest, and as you saw, you just annotate a test with that Micronaut test, and it works. It basically allows you to dependency inject the test and work with it directly. I can inject whatever components I want, assert the results, and write tests very simply. Okay, so that's like just an introductory overview of what like Micronaut looks like for those who weren't here. Now let's talk about what's new in Micronaut 4. So the base with Micronaut 4 we have baselined as a minimum version of the JDK 17, and we've updated and provided updates for JDK 21. We've improved the integration and performance with GraalVM massively. There's really significant performance and memory improvements. It's more modular. We have an expression language now. There's virtual threads support and a new context propagation, plus loads more. So in terms of like platform updates, like bumping all the minimum versions, Micronaut follows semantic versioning. So we only get to bump like 2 new major versions every time there's a new major release. And Micronaut 3 was baselined on JDK 8, sorry. So now the minimum version is JDK 17. or GraalVM for JDK 17. For the other languages we support, like Ruby and Kotlin, we also bumped them in a version. We bumped them in a version of Gradle 8. We bumped them in a version of Maven. Certain SDKs we support are now, bumped up. Things like Kafka 3, Micronaut 3 was based on Kafka 2 for the Kafka module. So basically, bringing all those things up to date with what's the most recent. For performance and memory, we have significantly improved the situation. So in Micronaut 3, on this machine without quick build flags, a native image takes 1 minute 20 seconds. Micronaut 4 is 1 minute. On Micronaut 3, native startup 20 milliseconds. On Micronaut 4 is 12 milliseconds. Reduce the native image size, the JIT startup, the jar file size. Everything is smaller, more efficient, faster, and we've kept optimizing. So we can see the net results of that in independent evaluations. It's all right me telling it, but there's independent folks trying it out, right? So Matt Rabel recently did a comparison, and I think we're doing pretty well. So as you can see in Micronaut is 4 is the first 2 bars there, and startup performance is, we're talking milliseconds here. I know it's like tiny numbers. Graal is amazing, but still, it's good that we're like winning the millisecond battle, right? And that's every little millisecond helps, right? There's actually 2 bars there. You'll see one is Micronaut 4 vanilla, and the blue one is Micronaut optimized. So I'll talk a little bit about that. That's essentially Micronaut AOT. Which is another layer on top of Micronaut. But as you can see, we've made significant jumps in performance. Also in memory usage. So Micronaut 3, just to make things clear, Micronaut 3 was behind in all of these graphs, right? It was behind the competition, that is. And now we're on par or ahead, right? So with native memory, again, we have significantly improved that. And actually, you really notice the difference with Micronaut AOT with native memory. It helps reduce a good 6 megabyte of memory consumption after 5 requests. So, and of course, you can tune this with your max memory flags the same as you do with the JVM. But things are significantly better now. So for GraalVM, we have improved build times, reduced memory consumption, and we collaborated with the Spring team on GraalVM metadata. So all of the metadata that is included in Micronaut for GraalVM for any third-party libraries. So Micronaut doesn't need metadata for itself, but for third-party libraries, whether it be Kafka or MySQL, or whatever. The GraalVM metadata to make those libraries work natively to deal with their cases of reflection. We previously had those in the framework itself, and there was the situation of what we would call what I like to call like kind of islands of compatibility, where you had like us, i.e. Micronaut doing one thing, the Spring team doing another thing, and the Quarkus guys doing something different, and these like islands of like GraalVM compatibility, right? So what we've tried to do is make that no longer the case with the GraalVM shared metadata repository. So whatever we contribute to the shared metadata repository will benefit Spring, and whatever the Spring team contribute will benefit us. And that's the way community should work, right? It's a collaborative effort. We also invested heavily in a lot more native testing, and I will demonstrate some of that as well. Every single Micronaut module that we release has tests, is tested, has a test suite, and we're now running those test suites with native image as well on every commit, on every PR. You probably are wondering why weren't we doing that before? We had a different test suite that kind of ran nightly on kind of downstream, and we found that it was often it caught issues later. So now we have a vastly more testing, and we also wrote a TCK for the HTTP layer of Micronaut, which verifies the way it behaves, all the features of the way the HTTP framework works. And that TCK is running against Netty, it's running against Jetty, Tomcat, all of the serverless implementations we support, Lambda, Oracle Function, all the different serverless implementations we support. The same TCK is running, and it's running natively, right, as well. So we have significantly more coverage, even on things like the HTTP layer, making sure it all works. And we've also leveraged Testcontainers and test resources so like Micronaut Data, for example, will run its test suite natively against all different databases, MySQL, Oracle, Postgres, the whole test suite, right? Against every driver, against every integration. Same thing on the R2DBC side. We have so much. I think there's probably not many projects that have the amount of testing to assure that the developer experience when using native image is a good one. So let's do a demo of Micronaut and GraalVM Native Image. So we've got this Hello World app, and first of all, you can with Gradle or with Maven essentially build a native image with native compile. So I can say GraalVM Native Compile, and that's one thing you can do. But one thing I have set up is an alias, which is GNC, I like to call it. I think at some point we're probably going to want to upstream this into like a CLI, and I think that's something we'll look at in the next year. But basically, like to activate quick builds. So the default in GraalVM is to like apply all optimizations, right? But there's a way where you can speed up your builds with by setting GraalVM quick build equals true as an environment variable. So just creating a little alias helps me build images quicker. So I can run this, and it will produce a native image of this application, which is basically just running GraalVM Native Compile. On Maven, it's MavenW packaging native image, and it's the same thing. And essentially, this will build the application into a native executable for this platform that I'm running on, which obviously is an ARM Apple Silicon machine, so it'll have to run on the ARM architecture and so forth. But it will essentially construct my native image and allow me to run the application natively. So as in quick build, we're looking at 30-40 seconds, and we can run the application natively. And as you can see, pretty amazing startup time. And if we go to activity monitor and see the memory consumption of that instance, so it's supposedly using 9 megabyte of memory after start. Probably after we make a few requests, it'll go up. I mean, this is a very simple application, right? Now, what's cool is we worked with. So first of all, I must point out that like the folks that work on Micronaut, we maintain the Gradle and Maven plugins for GraalVM, and we have built significant integrations with things like JUnit 5 and so forth. So those same plugins are then inbound by the Spring team. So we build and maintain the plugins, and the rest of the community inbounds them. So what you can do now is, you can run GraalVM native. It's basically GraalVM native test, or like I said, we have. I've set up an alias here, which is basically enables quick build and also test resources, which I'll talk about later. But basically, you can it'll run your tests, and then it will actually compile your application's JUnit tests. And right now, only JUnit 5 is supported. but it'll compile your JUnit 5 tests into native images and run them, right? And because Micronaut is like compatible with automatically with native image, it generally just works. You can compile your tests and execute them, and the world is good. And generally you would have these native tests running on CI, on your CI system, etc. So it'll build the application, and it embeds the JUnit test runner, and you get a little output of the test run, test found, and you get the XML reports spat out, and you can format those into HTML or whatever. So native testing is now a thing. If you do encounter a situation where you need reflection for whatever reason, we have some annotations where you can apply. So for example, I can say reflective access on here, and it will register the reflective metadata for this method, which is quite nice, right? And otherwise, I can go in and customize the configuration just using the official JSON format and so forth, and that'll work as well. So the other thing is Micronaut AOT. So if you go into here, so in production, we recommend you consider using Micronaut AOT because so if I do GraalVM native compile, it's going to use just the normal application. Micronaut AOT is like a post-compilation optimization step where you can provide further optimizations to the application. So for example, and these are documented in this link. So for example, I can say I want to use optimized service loading. If I'm using YAML, I want to convert the YAML to Java code, so I don't. So this is really clever because when you GraalVM has very smart dead code elimination from the native image. So you say convert my YAML logic to Java code, and then you don't need no longer need a YAML parser at runtime, and it eliminates the snake YAML from your image completely, right? Which is really nice. And there's another one that's not in here. I don't know where it is, but there's another one called like logback. Yeah, there it is. So so again, this is a really nice one. You say replace logback XML, and it generates the Java code, the equivalent Java code, to build your logback configuration, and then suddenly the XML parser is eliminated from the image. Right, so now you no longer have an XML parser in your native image because the dead code elimination in GraalVM has reached. Oh, I can't reach an XML parser, so your image gets smaller, right? Or your startup time gets better. I no longer need an XML parser, some of these things you have to be. I think these two. You have to be a little bit more careful, I would say. Because basically what this does is it resolves at build time the environment. So it means that you typically want to build on the same environment you're going to deploy to, because it's going to involve at build time it'll create like an immutable view of the environment that you're building for. And that has the benefit that AOT will eliminate beans and components that require some setting in that environment. So for example, if you have a particular bean that is only active in the production environment, and you build on your dev environment, then it's not going to be there in the image. You see what I'm saying? So it affects how. So these two are a little bit more. They actually change the behavior of the application at runtime. So that's why we actually have two images, right? Because they actually end up in different applications. You have native compile, which was like the default. So Micronaut is dynamic, and it will read your logback configuration. It will read your everything at runtime, your configuration, and it will reconfigure itself. Native will will apply these AOT optimizations that I've configured in here and generate an additional set of classes that optimize your binary further, right? Now this is an opt-in feature, right? It's optional if you want to go that extra mile to optimizing your application even further. Keep that in mind, right? When you consider using Micronaut AOT. So yeah, Micronaut AOT is essentially post-compilation whole world optimization on your classes, right? It'll actually, the way it works is it actually loads the application without starting it, and provides for example, if you have a bean that requires classes foo, and foo is not on the class path, it'll eliminate that bean and it won't be in the image, right? That kind of thing. So very handy, and continuing to push the boundaries of making applications smaller and more efficient and so forth. So as you saw, you can test natively with GraalVM. You can run native tests, and the other thing you can do is, which I didn't point out, is if you do have a reflection issue or something that's not working, or you're trying to integrate a third-party library, what you can do is you can run your tests, for example, and you can say /p agent, and it'll enable the GraalVM tracing agent, and then you can go in here into the build native agent output, and you can see generated config. We're working to make it better because it kind of includes everything, and there's a lot of config that's unnecessary, and you have to go fishing through the to find the types that are causing your error. But basically, it'll generate all of the native image configuration necessary to run the application. Then the GraalVM shared metadata repository. So it is, like I said, a collaboratively maintained repository. It is includes, there are Gradle and Maven plugins that let you use the metadata repository, and it has broad community adoption. So if you go to this link, you will find the metadata that exists today, and there's things for things like Netty, Hibernate, Kafka, all the configuration that used to be in Micronaut is there, and all the configuration that used to be in Spring is there into one merged, agreed upon set of metadata, right? It only includes reflection data, so what kind of resource config and reflection config. There's no opinions in the GraalVM reachability metadata on anything more controversial like build time initialization or anything like that. And as it happens, that's another big change in Micronaut 4 is that Micronaut, to align with Spring, moved to runtime initialization for everything, which is an important change, but we did that while still improving startup time. So if we build time initialized more, we could even improve startup time even more, but we haven't. Because I think consistency between JIT and native is more important than a few milliseconds of startup time. In terms of JDK updates, we have new, like I said, the new minimum version for Micronaut 4 is JDK 17. We have API enhancements that benefit from records and sealed types. We added support for virtual threads, and we cleaned up the code base because we had a lot of workarounds in the code base to support all the JDK versions, which were in there. We also have improved modularity. So we eliminated a lot of third-party dependencies. So for example, Jackson is no longer a third-party dependency, and we switched to Micronaut serialization. You can still use Jackson. We haven't taken it away, but it's now optional. Snake YAML is also optional. Caffeine is also optional. So we reduced the third-party dependency graph. We also split the compiler and runtime API, so we had like a lot of modules in the core of Micronaut where they were only used in the compiler, but they were there anyway inside your jar in your production app. And now we have a more formal split of these are like compiler classes, not part of the public API, and these are runtime API. And that allowed us to remove. We no longer repackage ASM because it's no longer in the application class path. It's only used in the compiler. So we don't see the need to repackage it. And we reduced overall runtime classes by 2 megabyte. We made a lot of core modules optional. Not everybody needs retry. Not everybody needs discovery. Not everybody needs validation. Maybe you want to write your own validation. I don't know. So we reduced the core to just like the essentials. And you can go adding these things back into your application as you go. We then, moving on to part 2, is let's look at the core updates to the core of the framework first of all. So here we'll look at like Jakarta, the dependency injection improvements, the general validation improvements, expression language, and things like KSV. So the great Jakarta migration. So we had like a little bit of a in Micronaut 3 we had like a mix of Jakarta and JavaX APIs because some third parties were still using JavaX, Hibernate, etc. and Hibernate 5, I think, and so we had this like mixed situation, and this was like a thing of the ecosystem as a whole, right, where we had to wait for things to catch up. So now everything in the JavaX namespace is gone. You can still use them, I think. A lot of them, at least, you can use the annotations and we translate them, so you can still use JavaX.annotation. I think JavaX.persistence, no, because it's required by Hibernate, the Jakarta one. But the new API is what you should be using. You should avoid avoid the left column, go for the right column, and depend on the Jakarta stuff going forward. So that's Jakarta annotation, Jakarta transaction validation, email, and persistence. Luckily, as part of the Micronaut 4 release, we released plugins for open rewrites. So if you're doing an upgrade, go to that link, and we try and automate as many of the changes as possible. So it'll rename all the imports from JavaX to Jakarta, for example. Because some things are optional, like Snake YAML and Jackson and a few other things, it'll put those back into your app if you depend on them, so that your upgrade is easier. And it's like a smart refactoring tool, right? Okay, so let's look at Micronaut for dependency injection enhancements and dependency injection in general. I kind of like brushed on it briefly. And what I'm going to do is I'm going to come in here and open this project up here. And right. Give it a refresh. Right, okay, so as you saw in the let's make that full screen. In the previous example, dependency injection is pretty simple. In Micronaut, you define scopes and so forth. So if I had like, I don't know, in here a kind of book service, whatever, and I add singleton to it, then that becomes a component that I can inject elsewhere. So if I had over here another component, let's call it book controller, I can either do @inject book service like so, or I can make it a final and inject as a constructor argument, right? So that's the kind of simplest thing you can do in terms of dependency injection in Micronaut, and we have continued to optimize and improve the performance of that and make it better. Now, one thing that we have done, and to demonstrate that, I'm going to write a test here where I'm just going to inject book controller, like so. And I'm just going to, for the moment, say assert not null, right? Micronaut is a fairly dynamic system, right? So where we have these like bin requirements, right? So you could say that, you know, this, for example, requires the property book service enabled to be set to true, right? So when you run that this test, for example, you can see that it fails because I have not set this property to true, so this component is not available, right? And in previous versions of Micronaut, we had worse error messages. So now when you have this kind of error, it'll say, you know, in Micronaut 3 it would say, you know, no such bean found, check your configuration, you know, figure it out with the logging, whatever. Now it says, you know, required property book service enabled with value true, not present, right? Because that's a requirement for the component to be active, right? So now as a developer, I know that I have to come in here and I can say, you know, take this guy and set him to true to, you know, in order to like make my test pass, right? So that kind of insight into debugging experience, I think, is a lot better in Micronaut 4. I think it's and it was more prevalent in certain things. So for example, maybe you had like over here, you know, store configuration, you know, something like that. And this was the name of the store and the location, and, you know, maybe like, I don't know, the capacity of the store, and maybe like the number of employees or something like that. Or, you know, let's just start with that for the moment. So what you and here, what you wanted to do was bind these as configuration properties. So whenever somebody specifies configuration under the store namespace, we bind from all of these things, right? And this requires as well that, you know, store enabled is set to true, right? Or maybe it just requires the store name, right, to be set as a minimum, and the default value, maybe you can define like a bindable default value here for the capacity of 50. Okay, so you know, Micronaut forever has supported this kind of like configuration where you can bind from like namespaces and so forth. And maybe in my book service, instead of this, I say like requires a bean to be active that is store configuration, right? So it's a dynamic system. So this book service is only present when somebody specifies configuration for my store, right? So like that, because it needs to like resolve the name of the store or whatever. So now, so we have some particular requirements. Also, we say that the, you know, store name shouldn't be blank. Maybe that we can add validation rules. Maybe this should be a positive number, etc., etc. Right. So we've defined like some configuration for my app. So if we test this out, we run this, it'll fail. So you can see that it fails because no bean of type store configuration is present in the configuration, right? So right. So we can see immediately that store configuration is missing. So we have to specify store.name, and we get code completion automatically for these kind of configurations. Amazon, whatever. And we run it again. You can see now we start to get better error message, right? So we failed to check the location parameter because it doesn't exist. So we need to specify some location, etc. And then we get a default. And if we specify any of those things as being like blank, for example, because we specified a constraint, you can see that we start to get validation constraint errors. So store configuration location must not be blank. So we've worked a lot on like the error messages and making the framework give you a better error message to know, when you have misconfigured your application. So that's really important. If I specify like a negative number here, again, it will fail for the very clear reasons. We did a thorough review of all the different configuration kind of error messages and trying to make those more obvious. Another thing that was common was sometimes this was like even more dynamic configuration, right? Where this was like each property, right? So I don't know if you've seen each property, but basically it lets you define multiple entries under a particular link. So that will fail now. So instead of store.name, you have store.star.name, right? So basically you can have multiple of these. You can have store Amazon, or whatever. I don't know, something, Alibaba, whatever. China, I don't know. And you can have multiple of these, etc. So multiple configurations. And then you could like look up like named versions of those. So for example, say I want to inject like the book service. Sorry, what am I doing here? Not that. The store configuration named Amazon, right? So if I do that, it's going to inject the Amazon configuration. But if like, for example, for some reason the Amazon configuration was missing in my configuration here, I just comment that out, I would get an error message that wasn't entirely clear, and now that's fixed in Micronaut 4. So now you get no b times store configuration, right? Exists for the given qualifier named Amazon. No configuration entries found under the prefix store.amazon. So it's telling you that you need to provide the configuration under store.amazon to make that work. So a lot of folks got confused with Micronaut data because it uses this pattern, right, of having multiple nested configurations. And then another thing that we have improved is now, you can, if we instead of injecting maps was always a bit awkward. So now you can say, give me a map of string store configuration and inject that. And change this variable. And for the moment, I'll just output it. And what you can see is when that gets injected, you can see that I get all the configurations grouped under the key that is the name in the in the YAML, essentially. I think I have one of them commented out, so I only have one. If I run this, you'll see that now I have like 2 of them, Amazon, Alibaba. So I can inject maps into maps of configuration or maps of other beans or whatever into my application, which is very useful. So map injection is really nice. Improved error reporting, optimized performance of the DI layer. It's really fast. We also have support for Jakarta validation annotations, and obviously that works really great with Micronaut AAP. So if I had a method here where I want to say book store configuration, find config for a particular store, and then just say get that one, whatever. For the moment, you can basically annotate methods, not blank, right? And have that validated, and that's been a feature. But now these are Jakarta validation annotations, as you can see. And in order to upgrade to Bean validation 3, we made things significantly better in terms of like generic validation. So for example, say I had under here a list of string employee names, right? Under my store configuration, employee names, whatever. What you can do now, which you couldn't do before, is you could say this is not blank, right? So each string inside of the list should not be blank, right? So previously it wasn't like possible to, in Micronaut 3, it's not possible to declare annotations on generic type arguments. And we've added that to the framework, so you can, and computation of all of that, compilation time and so forth. And it works really nicely. So, if I come in here in my configuration and I specify, and I specify, say, whoops, store.amazon employee names. Zero equals Fred. Zero Bob, whatever. Like so. Run that. Now it's passing. So, but if I were to specify a blank value here, you see it fails. Again, you can see that it fails because employee names, this element must not be blank. So we're actually validating those sub-elements, which is really important. So all of that is integrated into the entire validation system. So in this configuration, or if I had a method in here that took a list of string, find configs, I don't know, just making this up. But you can define them on method arguments or wherever. You can define them in bean introspections and so on and so forth. That was already demoed. So basically, yeah, Micronaut validation updates for Micronaut 4. We updated to the Jakarta validation namespace. We have added support for validations on annotations on generic type arguments. We have, that required like core changes in the framework. And the other thing that I forgot to mention as well is that validation is now optional, right? So in my build configuration or Maven, whatever, you actually have to now add a specific dependency on validation to include it. Otherwise, it's not included, right? So you can opt in or opt out of validation of your, depending on what you're doing, right? Not everybody needs validation, so it's now optional. So remember to add it back if you want to use any parts of the framework that require validation, whether it's validation, your configuration, or whatever. So yeah, you specify the dependencies in Maven or Gradle, and off you go. Okay, so one of the more exciting new features in Micronaut 4 is the expression language. So this thing is really nice. So if I had like a email job or whatever that sent a periodic email, and it worked with some email service, whatever, to send it, or maybe it doesn't. It's just a method, send email, and it is a scheduled thing that checks users and sends them a regular email, whatever, on a fixed delay. I'm going to put 30 seconds, and we're just going to system out that for the moment. Say sending email. Right? There we go. So if I run Gradle w run -t to start continuous mode, you can see that periodically I'll get this output saying sending email, etc. Some folks, are always wanting like be able to control things more in a more fine-grained manner, and with the expression language, what we've done is we've allowed expressions to be used. So, for example, I could have a Boolean enabled flag here, and generate new getter and setter or whatever to enable and disable the job, and define a condition here that says with an expression this only when this is enabled, right? And then I could write an endpoint that, or a management endpoint or something that set this to either enable it or not. So that kind of thing is really nice. And so where else can you use conditions? I'm going to be using conditions or expressions. Sorry, I'm going to be using expressions more later in my presentation, so you're going to be seeing them used even more. But essentially, anywhere there is an annotation value, and we have some interesting additional annotations. So, for example, there's one called root condition or route condition, where you can put on a controller method, and it provides access to the request. So you can provide a condition in here that says only route to this route if the request matches a particular condition. Otherwise, 404. Maybe it's a header. Maybe it's who knows. Now you're probably saying, okay, well we've seen this before in other frameworks. CDI. Why is this Spring EL? Why is this different? And how is this different? So it's different because in Micronaut, it's all compilation time resolved. So over here, if I make a typo here, you'll see that my application fails to compile. Right? It says the expression defined in the job, basically is invalid, right? So cannot find property name called enabled, so it's completely compilation time. It's reflection free, so it works with Graal automatically out of the box. So there's nothing to do for Graal. Those conditions will just work, and it doesn't allow runtime evaluation. So you cannot dynamically basically compile expressions at runtime, right? You might think, well, I might want to do that, but if you think about like Spell and history of Spring, there's been some significant vulnerabilities in expressions and runtime evaluation of expressions. It's a dangerous thing. The same escaping rules apply. You know, it's very constrained, but that's a good thing. It's more secure. It's type safe. It fails at compilation time, and it is more secure. So yeah, we'll be looking at expressions more, and in particular related to bean mappers. I have another demo of this. So this is a Micronaut 4.1 feature where you can, I don't know if you've used mapstruct, but basically you can define mappings between one object and another in Micronaut 4.1 without depending on mapstruct or anything. And I'll do a demo of that a bit later. So bean inspections, these have been updated as well. So for those of you who are not aware of bean inspections, so you know, if I had like a book class here, and well, let's make it a record, whatever, with a number of pages. What you can do with inspections is say, you know, this is inspected. And then what that lets me do is get hold of a bean inspection for the book class, like so. And basically instantiate book stand with 1,000 pages, etc. There it is. Okay. So that's basically what bean inspections let you do. So this is like one of the fundamental underpinnings of the framework, right? So Micronaut data, Micronaut serialization rely on this functionality. Now, you can see that the way it works is essentially at compilation time we produce a type that knows how to like instantiate this, and it also knows about the properties available on this class, the names of the properties, and it knows about, you can get more detail by getting the bean properties. And regardless whether you're using records or traditional Java beans with getters and setters, it provides the same API. Now, one of the challenges we had is that the API for records and getters and setters was different, right? So say, for example, so you can see, for example, here, I have to pass in the constructor arguments, right, in order to be able to instantiate the book. So I have to know that, you know, this has a title and pages, and I have to know ahead of time what those are. Whilst for a traditional Java bean, it would be something like you know, iterate over the bean property and then call set on. I would first like basically instantiate the object because I can, if it was like a traditional Java bean with like a public constructor, and then I would set the properties on it, right? So you know, on this book, set the title or whatever, and you're basically mutating an existing object. So there was no like unified API to you actually, if you had to be aware that it was a record, and you had to be aware it had constructor arguments, or it had setters, and you had to dynamically write your code. So what we've done with Micronaut 4.1 is instead what you can do is you can say introspection builder, and you get a builder for the book, and you say get builder arguments, and these are a combination of the constructor arguments and the mutable setters. If there are any in records, there aren't. But if it was a regular Java class, you get a combination, and then you can iterate over those, and you can say and when we have an efficient way to do that, where you can iterate over using array iteration, and you can say width for a particular index and a particular argument, set the value, etc. Now, and then once you're done, call builder.build, and regardless whether it's an argument or not, a record or a Java bean, you can construct it with the same API. So that simplified a lot of code for us. But more interestingly as well is that we added support for builders as well. So actual builders. So typically, and I think I had a code snippet here. So for example, if you had a person record here, right, with a name and an age, maybe you would have a child builder, right, where the builder was responsible for constructing the object, right. So now we have a third approach that's typical to be able to construct objects, and sometimes I can't actually construct the object. In this case, I can because it's a record. But if this was a type with a private constructor, I wouldn't even be able. I'd have to use the builder. So now in the core, we have this notion of defining the builder for an introspection through where you can say the builder class is person.builder.class, and it'll let you use the introspection API via this builder stuff to construct the person object. So this is probably a lot of detail in like why would we do this? And fundamentally, the reason we've done all of this work to support builders is because a lot of people that we found are using builders with JSON serialization. So they're using builders to construct the object, and then to deserialize, you have to use the builder. So in Micronaut serialization, there is, and Jackson, there's a JSON POJO builder annotation. So now in Micronaut serialization, that's supported as well, right? So you can serialize and deserialize builders in JSON and in Micronaut data and everything. So like I said, introspected is a fundamental building block. So like by default, we've had support since the beginning for like Java beans, but now there's a transition to records, and then we also have different ways to construct objects, from builders to static methods, and we have a complete solution to deal with all of those in the same manner, right? With a single API to deal with all types of object construction, whether it be records, Java beans, builders, whatever, right? We can, and because this is a core foundational piece, that means things like Micronaut serialization, Micronaut data support all these concepts, right? Which is critical. So to use the new builder support, and this is in 4.1. You just define the builder class. You can customize the builder method, both the builder method and the builder method name, and it allows you to essentially use a builder-like API where you provide the name of the property, or if you know the index, you can provide it ahead of time and the value, and that's it. JSON serialization being a lot easier. So for Kotlin users, we added support for Kotlin symbol processing. Do we have any Kotlin users in the audience? One. So Micronaut's previous implementation was based on something. Well, it's still there. It's based on KAPT, which basically what it does is it lets you run Java annotation processes with Kotlin, and it works by when you compile, it generates a Java stub and passes the Java stub to the normal Java annotation processor API, and the Java annotation processor API interprets the Java stub and produces whatever it produces. So we had a lot of bug reports because with KAPT, essentially what happens is we see the Java stub, but it doesn't represent the original Kotlin code. So we don't see things like named arguments, Kotlin delegates, lots of constructs that cannot be represented in a stub, if you see what I'm saying, in a Java stub. Because there's no way to express those in Kotlin. So I think that KBT usage in general, especially in the Android ecosystem, obviously suffered from the same issue. The other problem is the process of generating stubs is long. It can be long on large applications because you have to generate all these stubs. So it's like a two-phase compilation step. So KSP is from Google. It's a project that has come out of Google, but I think it's a joint collaboration between the JetBrains folks and Google. And it's trying to build a replacement for KAPT that is Kotlin native. So it has good sides and not so good sides. The good news is that it doesn't generate stubs. It is faster incrementally. And we can fix all these issues of not seeing the native syntax. The less good news is that it is still young compared to KAPT. It doesn't support Java annotation processes, so all existing Java annotation processes, whether it be map struct or whatever, or anything else you may use, doesn't work with KSPP. And it's Gradle only. There's no Maven support. So those are the downsides, but it's promising, and we support it in Micronaut 4, one of the first frameworks to support KSP. So excited, and we have a lot of Kotlin users who are excited about that. Okay, so let's head into the web tier, and soon we will stop for a break. Never fear. So the web tier, we have support for virtual threads, experimental support for HTTP 3 and IO-Uring, new client-server filter APIs, support for Micronaut, default support for Micronaut serialization, so Micronaut serialization is the default. We have a new control panel and a rewritten context propagation infrastructure in Micronaut 4. So, virtual threads. So, virtual threads have landed officially in JDK 21. So they basically, for those of you not familiar with virtual threads, they're designed to basically allow you to scale out blocking I/O in a more, in a better fashion. So what does that mean? Essentially, what happens is instead of there being a real thread, i.e., a carrier thread, the JVM runs virtual threads. And these virtual threads, when they encounter a blocking operation or a blocking I/O call, such as an HTTP request or something, they are able to detach from the carrier thread and allow another virtual thread to take over the carrier thread until a response comes back. This is nice because now you can, a lot of developers find blocking I/O easier to understand, right? You make a request, you get a response. There's no like reactive async kind of callback scenario, which can be confusing for a lot of junior folks. You just make the blocking call, you get the block, and this is good, right? You can potentially write blocking applications which are easier to understand, easier to reason about. However, so first of all, Micronaut fundamental non-blocking architecture benefits from virtual threads because the blocking calls you make have to use a asynchronous library under that doesn't pin the carrier thread. So there are various circumstances when the carrier thread can get pinned. Those include things like JNI calls, things like synchronization blocks. So not every HTTP client, not every library out there is yet is maybe ready yet for, and it's quite difficult to know, have I pinned the carrier thread, right? Because most developers don't know, have I pinned the carrier thread, right? So it's still early days for the ecosystem to adopt all of this. But the good news is with Micronaut it works, so you can, because Micronaut uses Netty under the surface for its client, when you make a blocking call, it'll unpin the carrier thread and allow another, because fundamentally asynchronous under the surface. Another important thing to note is that virtual threads are not good, well, not good, they're not a great solution for CPU-bound operations. So when you run a CPU-bound operation, i.e. a job that's going to take some time or something that's going to do a lot of processing on a virtual thread, the carrier thread is pinned for the entire time of that CPU operation is operational, right? The only time the carrier thread is released is when a I/O operation allows it to be returned and resumed. So that makes virtual threads a potentially good solution for a lot of problems, but it's not the silver bullet. It's not all problems, right? If you have a lot of CPU-intensive work, you probably will still need a thread pool somewhere in your application. So now the great thing is that there's not much that you have to do to enable this in Micronaut. You just set Micronaut server thread selection to blocking. If you're running on JDK 21, it'll automatically run all blocking operations on virtual threads. If you're running on earlier versions of Java, it'll use an I/O caching thread pool that expands and contracts, caching-based thread pool. So that's really is the entire story in terms of blocking threads. Now there is going to be more, as you know, Netty, for example, Netty's model, and generally the non-blocking I/O model is not has not been yet adapted, or like the actual Netty event loop usage of things like I/O, U-ring, and epoll actually pins the carrier threads. So you can't make Netty run virtual threads. So when you do this, basically what happens is Netty receives the request on the event loop, and it offloads to another thread, which does the blocking operation. Right. So that's why we call this thread selection, because it's saying that you're going to run every incoming request on a particular thread. So you pay a little bit in terms of the context switch, right? Versus if you didn't do blocking and kept everything on the event loop and never context switch, which would scale better and potentially, but yeah. So there's lots of caveats, but they're here and they're ready. They can be used in Micronaut 4. And I think for a lot of use cases, if your application is primarily making a bunch of HTTP requests, it's a cool solution. So in order to get Loom, Micronaut ready for Loom, we came up with new APIs for writing filters. So why new API? So now you can write annotation-based request and response filters. Before we had an API where you had to use reactive programming to write filters. So what Micronaut does is when it knows you are executing a route that is blocking all the way through, and it knows it's running virtual threads, it will not use reactive structures to execute the filters, and therefore collapse the stack traces and make them much shorter and improve performance. Yeah, so if your filter is not doing any kind of blocking operation, such as invoking another service or whatever, you can potentially run completely without any reactive stack trames. And our HTTP throughput has benefited greatly in Micronaut 4. So Micronaut 4's HTTP throughput is about 50% improvement from Micronaut 3. Yeah, so significantly faster. We also have experimental support for HTTP 3, which is UDP-based, so on both the client and the server. Now, this is based on modules in Netty that are themselves experimental, incubating. So the whole feature is experimental, but it's there. And you can try out HTTP 3 and build HTTP 3 applications today. with Micronaut. Okay, so I think I'm going to head and we will stop for a break now, 15 minutes, and then do the last hour, and give you a chance to have a drink and ask questions if you want. If you want to stay behind and ask questions, then that's fine too. Welcome back, everybody. Hope you had a good break. So let's carry on going through all the details. So in the next section, we're going to look at context propagation. So I think context propagation is probably one of the most challenging problems for a framework, especially like Micronaut. So we had one solution in Micronaut 1, another solution in Micronaut 2, another solution in Micronaut 3, in order to support the different context propagation possibilities, right? And so we really wanted to get it right in Micronaut 4, and we because a lot of the context propagation APIs and instrumentation APIs were all marked as experimental or evolving in earlier releases. So and we took like inspiration from Kotlin coroutines, context propagation, and so forth. So what the fundamental problem is that you have different types of context propagation, right? So for example, if you are trying to propagate MDC logback entries, right, in a synchronous mode, it's relatively a lot of folks use thread local, right? You bind the request ID or in MDC to the current request. But if you have to support something that also needs to propagate the context, if it's a reactive flow, or if it's Kotlin coroutines, or if it's now Loom virtual threads with scope values, we need like something that an API was flexible enough to deal with all the different possibilities, right? And also we had other cases of context propagation in the framework. So, for example, Micronaut data transaction management, right, which was coupled to the thread local model of managing transactions. Micronaut data itself now supports different ways to do transaction management, because we have Micronaut data R2DBC, we have Micronaut data Hibernate reactive, we have Micronaut data MongoDB reactive. So we needed a way to be able to also do context propagation for Micronaut data to propagate the transaction management such that you can commit and roll back transactions. A lot of folks were also asking for OpenTelemetry support. So we wanted to base whatever our OpenTelemetry support was on the new context propagation API, so we were putting it off. And then there's also new support for context propagation in Micrometer. So as well as a new module for Micrometer called Micrometer Observability. And we're introducing Micrometer Observability support in Micronaut 4.2. But basically, this is a common problem in microservices or in general in applications, is to be able to provide this kind of telemetry and propagate the context from one thread to another, from one invocation to another, from one. So we have a new context propagation API, and it's integrated with the way you do the annotation-based filters. So, for example, if you want to do MDC stuff, you can inject into your filter the mutable propagated context, and, for example, get the header from the request, put it in MDC, and then add the MDC propagation module to the propagation context, which will integrate with it such that regardless whether you are using underneath the surface synchronous code, which can use thread local, or reactive code, where we use the reactive propagation context, or whether downstream in the future, for example, with virtual threads, we could use scope values. So, so we've added an official supported way of doing this and propagating the context, and loads and loads of tests with different arrangements and trying of context propagation. And it's very challenging space to get right. And I think we have so much test coverage in this area now that we're confident, way more confident than that the context will be propagated correctly across different reactive flows and threads and whatever else throughout the framework. Let's move on to Micronaut data. So Micronaut data, if you are not aware of existing equivalent solutions, you have things like Spring Data and GORM that came before it. And they rely heavily on reflection and runtime proxies. With Micronaut data, we compute queries instead at compilation time, unlike these existing solutions which are not type checked and so forth. And so Micronaut data is like a reimagining of the data access repository pattern to basically pre-compute queries in the compiler. It uses Micronaut's reflection-free AOP modules, and basically it's like zero runtime overhead. We have smaller stack traces, compilation time checking, and we've done benchmarking, and there's literally zero overhead for Micronaut data invoking a query versus like you doing it yourself, right? So it's very efficient. And we have an expanding surface area of implementations. In Micronaut 4, we have high-binary reactive support as well. We've got Micronaut data JDBC, R2DBC, MongoDB, which is built on Micronaut serialization. We got support for Oracle coherence. We added support for Micronaut data Azure Cosmos, I believe, for Azure users. So there's lots of different implementations. And partnered with Micronaut data is our really awesome integration with Testcontainers and automatic container provisioning. So we have built a module for Testcontainers that is based on the usage of Gradle and Maven plugins that spin up the test containers in a separate server to host containers, and allows you to reuse containers on a shared server. So you might be wondering why we did this way, and I'm going to demonstrate through a series of demos why this is awesome. One of the main awesome things about it is you can natively test applications using the shared server, so you can run native tests, and development mode restarts don't suffer, right? So with that in mind, I'm going to do another demo, and I'm going to show you exactly what I'm talking about. So first of all, the way our test containers integration works is just refresh that. All right, there we go. Okay, so the way this works is that I have the test resources plugin for Gradle applied, and we have Maven integration as well. And the way it works is that when you have missing configuration, our test resources integration tries to fill that in. So you can see that I've got some database configuration here that says I'm using MySQL, but no actual URL specified of where, or password, or username, or anything. Because typically it's better to specify those things externally anyway through, a lot of people use secret management service if you're deploying to the cloud, or environment variables, or Kubernetes to manage it, or whatever. You specify them in the URL, the password, the username as environment variables. So those are not specified here. Or you create like an application.production.properties and add that to your class pipe before deployment. But what's cool is if I do Gradle w run /t to activate development mode, or continuous mode, essentially. Whoops, what happened there? Hold on. That's weird. Let me just stop. Okay. So when you, why am I getting this now? Address already in use. Oh, that's probably because I have something already running. I'm not sure what I started or when I started it, but I'm just going to do the brute force method of killing everything, so I'm not going to get port bind errors. Okay, so there we go. I had something running in the background. Sorry about that. So as you can see, when I start up the app, it starts up my Testcontainers integration and starts up my MySQL container, and it's running in the background. So even though my application here depends on MySQL and sets up a data source for it, just by running the app, I don't need to set up a separate container. It's just there. Now the cool thing is, if I make a change to my app here, and just say starting up, whatever, and we look at the output here, you can see that Micronaut basically restarted the server, but the container didn't restart, right? So I have a really nice development experience of the separate test resource server keeping my container running, my MySQL container, and I can make changes to my app, and it'll automatically restart without restarting the container. So, and what's cool as well is if I come in here and I say, run my tests, for example, you can see that my tests are reusing the container from the running application, right? So my test execution is not suffering because I've added test containers to my path. My tests are still executing lightning fast because the container is already running, right? So I get this really great development experience of the test resource server managing my containers, and I'm able to carry on developing. So the test resource stuff is really nice. And of course, I can build, Micronaut data applications. So, I can add let's just do the whole book demo again. So, I can do, title. We can use records. And what we can say is this is a mapped entity. And it has a long ID that is a generated value, and that is the ID, right? So with Micronaut data, JDBC, and mapped entities and records, it provides a really slick experience. You can provide alternate constructors if you don't want to have to specify the ID every time. Just supply null, and I can define a record that models my database table. So this maps to the book table in my database. And now what I can do is I can define a book repository in order to, and that extends from CRUD repository and uses the book and the ID. And we can say that this is a JDBC repository with the dialect of MySQL, right? So what we can do now is come in here, and you can see we can inject into my method my repository, and we can say just add a simple assertion here for the moment equals 0 repository count, and run this. And you can see that it executes instantaneously. even though it's doing database access logic, running a query, and so forth, because my test resources, test containers integration is keeping that container operational for me, which is really sweet. So that's how you basically model a kind of book entity and so forth. Now, one of the things that is nice with Micronaut 4, and it's new, I talked about annotations on generic type arguments, but one of the changes we made for Micronaut 4 and Micronaut data is that in order to allow the developer more control to decide when they want validation, because sometimes database access logic is performance critical. And in Micronaut 3, validation was always enabled on all repositories, right? And now, as I said, we have this more modular approach where you can either use validation or not, right? So now, by default in Micronaut 4, validation is not enabled by default. But it's really easy to re-enable it with generic type arguments. So, for example, I can say that that the ID here should not be null ever passed in, right? And that'll make all methods that take the ID. So if you look at the parent class here, there are some methods that take the ID, like find by ID, exists by ID. It will make sure that they are not null before they're invoked, right? So you can say the book should be valid, right? So we can actually reinstate really easily, and that's why we made it optional, because we didn't want to take this away without making it easy to put it back, right? So now it's really easy to say, for all my methods, make sure my book is valid. So in this is CRUD repository, so that'll make sure that when you call save or when you call update, the book is valid before that insert happens, which is nice, right? So that means if I come in here and I have annotations in here that says this shouldn't be blank and this should be a positive number, then those get reflected in my validation rules, which is very nice. So now the cool thing about Micronaut data with regards to querying and so forth is you can write queries and maybe before I will save some data and we can generate that. So for example, I can say save new book and say this is a standard or whatever. There's 1,000 pages, etc. And I get the book back. And why do I use the return value? Because this is using records, and what happens is when Micronaut data does the insert and the ID is generated, it uses a copy constructor approach to return a new book with the ID populated. So we can see here that if we write a test that says book.id is not null, that will be the case. Now, what Micronaut data does for you is obviously write all those nice queries for you. So obviously, you can say find by ID, to just use one of the pre-existing methods, and that will clearly work, etc. So we run that test and pass it. But you, of course, can write custom logic. So I can say, find by title, stand, and return me the book, and create that method for me, implement it for me, etc. And it'll do the right thing, right? So there's kind of common methods. What have I done? Missing something. Can't find symbol. Oh, that was weird. Okay, so I must have missed an import or something. Or I was too fast in running my test before I saved my code and got the buffer. So yeah, you can write this kind of logic. Now the cool thing is that if you make a typo, like here, you can see you get like type checking. If I tried to run this test, you'll see that it'll fail with a compilation error. So you get active type checking that what you're doing is actually the correct thing. Of course, like you can define your own validation annotations on your repository, so they'll just pick up your arguments and intercept them correctly, which is really nice, right? And then we can start creating the API in here, and basically inject your repository, etc. And add, for example, to get all the books. Now, the reason I want to demonstrate getting the API is because I want to talk about Micronaut serialization. So for example, if I do this and write an API endpoint to find all the books, and then maybe write a client over here to make that call and talk to the books endpoint like so. Get all the books. This is going to obviously run on a different thread. Like one thing we could do is write a startup event listener in the controller just to initialize some data. Make this transactional, right? And save a couple of books here, just so that I want some data to come back from my endpoint to demonstrate Micronaut serialization. So I can do things like individually, like save, and this will run in the same transaction. I could also use save all, which would be way more efficient because it'll do a batch insert instead of 2 inserts. Just keep that in mind that you have both save and save all, and save all is smarter and will do JDBC batching. So that's going to save 2 books in there, and what I can do now is let's write another method to kind of test my client. And we're going to make a call to the client to get all the results. And let's just say, now I'm expecting this to fail, just so that you're aware ahead of time. So if I run this right now, I'm going to do my full HTTP integration test. It fails because no serializable inspection is present for type book. Consider adding settable. So this is where Micronaut serialization comes in. So Micronaut serialization is a library for Micronaut that supports build time computation of serializers and deserializers. So it doesn't, unlike Jackson, it doesn't let you just send arbitrary responses and serialize everything because one, we need the build time information, and I think arbitrary serialization is probably quite insecure default. So you actually have to come in here and say, I'm going to explicitly say I'm going to make this type something that can be serialized, which is probably not a great idea necessarily if you're building an API. Definitely, you probably don't actually just want to be serializing your database entities as is. But to get the test to pass, you can see it's running on a virtual thread. And executing that query, you can see that basically I made it pass, and now I can send books back and forth over HTTP using my client. But I don't think this is like, typically one of the goals we had with Micronaut data is like typically it's not the best of practice to just like send your entire database table or over your REST API. Typically people have either a subset of the data or so forth. So if I had a more complex data model here, for example, maybe we add another record to that model is like the author table, and this has a generated ID value that is the ID and the name of the author, and this map is also a mapped entity that maps to the table, maps to the author table. And now over here we have an association. Now we have a more complex data structure where we have an association between two entities, and obviously that requires a different arrangement. So we could obviously make another interface, which I'm not going to bother creating in the class. I'm just going to do it in here. It extends CRUD repository, and allows me to persist authors, and again JDBC dialect of MySQL. So I now have two repositories, and we can probably line up our SQL our queries correctly, make that final, and inject both repositories. And probably now we have a greater need for transactions where we're going to essentially persist an author and create an association between the two entities, right? Oops. Right. So now I imagine if I run my test again and try and do the same thing, it'll probably fail, and it's failing for a different reason. I guess because my test over here needs updating. So let's just remove that test for the moment, just so that we can progress the demo. But basically, if I run this, it's going to fail as well. And it's failing for a different reason. It's because I'm trying to read from the database books, basically calling find all here, which is calling find all over here, which is one of these inherited methods. But Micronaut data JDBC, basically encourages you to kind of forces you to say, if you're going to query stuff, then you have to specify your joins, right? Because we made a conscious decision not to support lazy loading, which I think is still problematic in Hibernate. So now you have to come in here and you can say I want to join this data on the author column, and if we run this, it's still going to fail, which is expected because now it's saying my author is not serializable. So the Micronaut serialization is aware of like object graphs where this needs to be serializable, and then you have to maybe start like making your whole database model serializable. But if you start doing this, then now it's passing. It's probably not the wisest thing. I mean, I'm getting a big chunk of like data back here. Probably if I enable like trace logging, you'll see what I'm talking about. But basically, if I go in here and I say I'm going to enable HTTP client tracing, right? When I run that, and we look at the logs, you can see that what? Maybe that was weird. You can see that I'm getting like the ID, the title, the stand, the author, the big JSON graph of things. But like a lot of applications are not that simple, right? You want and generally, I don't, you don't want to. You often don't want to expose your entire object graph over JSON. So with Micronaut data, we put a lot of effort into making sure that it's possible to do projections. Maybe I have like a book summary, and this is serializable, and it's a record, and it's only I'm only going to get the title and the number of pages, right? And what you can say with Micronaut data is, I want to list all of the book summaries, right? Instead, and return that. And Micronaut data will produce a optimized query that, if you look at the query itself, it's only getting the title and the pages from the book table and not everything else. So we made Micronaut data like smart in that you can select subsets of the data with data transfer objects, right? And it's really smart because if you model a data transfer object incorrectly, like for example, I'll make a typo here, it'll actually say, I can't implement that because property page is not present in the entity. So you need to, it'll only let you join in data that's actually modeled in your entities. And that way you produce a lot more efficient queries, and you don't need to specify the join here because it's only going to get that. Now in Micronaut data latest release, we also allow specifying like author summary and getting the author to deal with associations or a subset of the author, which is nice because you can select these subsets and so forth. And this works really, really nicely for a lot of different use cases, and lets me write some like really efficient queries. Obviously, this works. I'm doing this on list, but I could return book summary from here, and I would implement that for me for only the subset of the data that I need, right? And I think it's better, to make this like serializable, this data transfer object, rather than like making your entire like entity graph. So typically, Micronaut data is a lot about like using one set of types to define, like model your whole table and maybe insert that data. That's useful. But then when you start writing queries, you realize it's better to use subsets or records to get just the data that you want, just the title, just the pages. And of course, I can also write selection things. So, like for example, you can write queries like int find pages by title, and Micronaut data is smart enough to figure that you want to select the pages property and return int. Which is pretty nice as well to do those kind of projections, and you can do like averages and maxes and all sorts of things. Now, one of the things that you can use expressions for in Micronaut 4, which I think is really nice, is if you have like more complex requirements. So, say for example, I want the title of the book, and I want the author name, and I want to do a price, right? So I want to get all this like different kinds of data back. Now, like typically you'd want to read this like from the database, right? So, we could come back in here and say, let's reinstate that join, because sometimes, like, obviously it's good to get SQL to do as much as possible, but it's not always possible to get SQL to do everything that you want, particularly if there's other microservices involved. So imagine, like, for example, I've got a pricing service that's going to calculate the price. And this is the entity that I want to serialize back as JSON. So you're going to get a book. You're going to get the author name. And then you want to compute the price from the pricing service and then return the summary, theoretically, right? So this is where beam mapping in Micronaut 4 is really, really nice. So what you can do is define a class. Let's call it book mappers, whatever. Let's make it singleton, and let's make it an abstract class. And let us theoretically, there's like a pricing service, right? I mean, you could have interfaces or whatever, and, and we're going to compute the price of the book. Like so, and maybe just use one price for everything. There we go. Whoops. Like so. Obviously, there would be more complex algorithms for pricing that this demo is not going to represent. But anyway, so and inside mapper here, you can say inject the pricing service into here and add a constructor parameter for it. And what you can do is you can say, I'm going to say get a book summary back, and I'm going to map my book entity to the summary. And we're going to make this an abstract method, right? And what you can say that the mapping, right? And you can add a static import for that to the author name property. Uses an expression, right? That gets the book.author.name, right? So that's how I'm going to compute the price, and then the author name by traversing my object graph, and I'm going to add another mapping that is going to calculate the price, and it's going to call is this had calculate price, whatever, book. Probably there, I could have called the service directly, but this is the pricing service, calculate compute price, book, return. Okay, so, and the price I'm going to say, I'm going to compute it from this dot calculate price book. So I'm going to define an expression to compute that, and all the other properties are just going to be like auto-mapped. String pages, they're just like automatically mapped. These are the exceptions, like when I need custom behavior. And then you can just inject my book mappers into my application. Maybe we do find all stream map. This book map is map. I think you probably just do two lists nowadays in more recent versions of Java. So I'm retrieving the books, and I'm calling list.map, which is implemented for me by Micronaut. It will compute the author name property using an expression that traverses the object path. It'll calculate the price, delegating down here to a method. And if the demo guys are with me, it'll work. No. So let's see. Unable to author name. Hold on. Yeah, I need to get rid of that. Okay. So what did I do? Oh, I see. So in my client, I probably need to deserialize book summaries now. And there we go. So passing. So now I'm exchanging book summaries. You can see that the response coming back has the standard pages, the author name, and the price. The price is coming back as a string. What's cool is you can do this make things even better. So you can define like number formats. This is going to be dollar. We're going to deal in dollars here. 0.00, whatever. And we can update that mapper. And now getting prices coming back in dollars with a dot. So mapping and expressions are really cool. And obviously, like if you make a typo, this fails to compile. You can get these mapping methods to be implemented automatically for you, and that's, Micronaut data does a lot in terms of and obviously you still want to optimize your queries to select a subset of the data, but there's lots of use cases where, you, for example, if this pricing service was another microservice, you would need to map and then retrieve the price, and it doesn't involve the database call, right? It involves an HTTP method call. So this is where book mapping, if this was another microservice call to compute the price for the book, it lets you kind of compose your application in a different way, in a more efficient way. And obviously you only need to define mappings for the exceptions, the mapping between book and book summary for things like title and pages is automatic, right? And so that's a really nice feature of Micronaut 4.1, right? So that came out recently. And if you're familiar with map struct or anything like that, it's very similar. And of course, with the test container basically running all the time, you can do things like run your oops, what something failed there. SQL error. Oh, yeah, probably running my tests at the same time. Yeah, I need to stop that. But basically, you can run native tests, and if you run native tests, it will compile this application into a native image and run my test suite that I've been building here against the running container. So this is cool because most test container solutions, they embed test containers in the same JVM as you're testing, and that means that you have to make sure that the whole of test containers is compatible with native image. And this means that you can actually, and all of our testing infrastructure for Micronaut is built on this technique of essentially using a separately spawned test resource service that runs in a separate JVM, and all the kind of as Micronaut requests configuration, it loads up, and you can see the native test passed, right? So and executed successfully. So I'm running native Micronaut data tests that are using a MySQL database. They're using Micronaut data and everything, and it just works, right? Which is really nice. Okay, so Micronaut data in Micronaut 4, we rewrote the transaction management with support for reactive transaction management. We decoupled it from validation, so now, but you can still add it back easily. We added support for Hibernate Reactive. We added support for Oracle Database JSON duality views. So the latest version of Oracle Database has the ability to define these JSON views that if you update the view, it updates the relational table, and if you query a relational table, it updates the view, and it's a really cool feature because you don't have to choose between relational or document. It's like one, and we added support for that in Micronaut 4, so you can, and it uses Micronaut serialization under the covers, so you can serialize JSON to and from Oracle Database. Okay, so another important module that's been updated is significantly is Micronaut Open API. So this for those of you not aware, there's two modules. There's the original module for Micronaut API where I can add it here. And basically, it's an annotation processor plugin. You add it, and you add the Swagger annotations. And then what you can do is you can come in here, and you can say, this is my open. Probably I need to refresh. This is an Open API definition, and the info like so. Title, bookstore, whatever, version 1. We save that, and since I have the test resource stuff working, there's also like support for Swagger UI, so just by setting a few settings, you can expose the generated Swagger UI. And then if you go to a browser, oops, you are not. Hold on. There we go. Right. So just by adding an annotation processor, you can see that my kind of books API definition is automatically generated compilation time. So you can see, and it's smart because it generated my API, but it's also generated the schemas. So if we look at the schema for book summary, we can actually that's true. I haven't added some, like if I go in here into my book summary and I say that this is not blank, and this is positive, and not blank, whatever. You add these kind of requirements, then what will happen is the schema will start to reflect that. Takes a little while to. Yeah, there you go. So the minimum length 1, pages minimum 0. So as it's aware of Micronaut validation annotations, and it adapts the schema automatically. And the other thing that's really nice is, so it's obviously discovering that this find all method is here, And of course, I can like add more endpoints, to maybe find by title or something like that, or just I'm too used to like Micronaut data stuff, so we can add some more endpoints here, and then write a find by title method. Then we create, and this can return a list of book, whatever, or just a single book. Or maybe we should do optional. Huh? Always a list.
It's always a list, never in primary key.
Right. Yeah. The thing is, if you have a single one, it'll adapt the query to return the first result. But yeah. So we can do something like this. For example, there we go. And we find by title, and we implement that, and we can say that this shouldn't be blank, and do some kind of validation, and then what you have is your API being like built for you. So we've added the title endpoint. Now what's cool is if I start adding JavaDoc, right? I can say this is finds a book by title, by the title of the book, a book or 404 if it isn't there, and we start like documenting our API in JavaDoc, and then you'll see that those JavaDoc comments start appearing in the generated output. So we actually, because we're an annotation processor, we can look at the JavaDoc comments, we can produce like quite accurate documentation for the spec. And all of that is based on like the source code processing, right? Now you can customize it. So for example, with Swagger annotations, you can say like this. You can add tag, for example, and I'm adding tags for a reason. I'll talk about that later. Like this is part of the book API, whatever. You can add like custom API response customizations, so response code like for description if a book is not found. So you can further customize as thing to customize the output that gets generated. So we can see that the 404 condition gets updated in the Swagger, which is very cool. So this module has been out for a while, but it's getting better and better and more complete and more complete. And it works at compilation time. So in the build directory, you'll see that there is synchronize. You'll see that a YAML file gets built, right, of my API, which is very cool. But some people like the other way around, right? So this is basically Java source code to OpenAPI specification. Some people like the other way around. So say you get to the point at the beginning you're using OpenAPI and you're generating a spec, but then later you want to like, do the other way around. You want to do spec-driven development. So what I can do is I can create a OpenAPI and add my bookstore YAML. I'm just using the generated one, right? And we have new modules in Micronaut 4 that integrate with the OpenAPI generator project through Gradle and Maven plugins. So I can just activate the plugin. And then I can generate client stubs. So I think I have slightly different. Yeah, and you can say whether you want it to be reactive or not reactive, etc. Another reference. Oh, I think. Hold on. Just go with that a minute. Refresh. I think I am, yeah, missing a level of nesting in here. Okay, file name is 1.0. Thank you for catching that. There we go. So I don't know if I'm just going to restart this. I don't know if the continuous mode would have done it. But basically, what have I done? Property destination of file specify source API bookstore does not exist. So what have I done? Source main open API. Okay. So let's try that again. There we go. So it generated my client. If we look in the build sources here, we can see my client APIs. I have a book API. Looks like it's called API. So the OpenAPI generator thing is a bit curious, the way it works, in that it uses tags so that you can, like, I knew I'd explain why there were tags here at some point, but it basically uses tags to group API operations in interfaces. This is just like a quirk of the way the OpenAPI generator open source project works. And it'll basically generate me the API. I think. Oh, hold on. It's because I moved this here. Okay, let's just call it books. So it uses the tag for the name of the API that gets generated. Okay, so what you get generated, as you can see, my client. Here I have a generated client, right? I don't know why the book summary is returning void. That's weird. Something I have done wrong here. But basically, you can inject this. So I can inject the books API, which is generated. And I can call it. And it generates its own model classes, right? So because typically you would have this in a separate project. You wouldn't have this. You'd have one project with the API, and now I have a project where I can call find all book summary. The only other thing I need to do is you need to set the so the destination of the client is set through a configuration property. So you have to say base path equals, whatever. Let's just do the local server. Typically you would reference here instead a service ID if you're doing service discovery or whatever. And there's all sorts of customization options that you can use. And I don't know if this is even going to work, but hopefully, first time I'm doing this. So okay, it worked. Right. So there you go, making the request via the generated API from our OpenAPI plugins. And we also have, I'm not going to do it demonstrate it, but there's also a possibility to generate the server stubs. So if you generate the server stubs and then you implement those stubs, and you can generate the client and the server stubs, implement the stubs on the server, have the client for free, and you can build spec-driven development. OpenAPI is spec-driven development, basically. So the inverse of what we had before, which was Java to OpenAPI spec development. So, and we have plugins for both Maven and Gradle for this, which is pretty awesome. So generate specs from Java sources, generate sources from OpenAPI specs, and it's based on the open source OpenAPI generator project. You can generate clients. You can generate server stubs that you implement in your logic, and from an API definition, and it supports OpenAPI v3. If you want to find out more about Micronaut data, you can access a whole bunch of guides that we have on Micronaut data, and all of them are using Testcontainers and updated for Micronaut 4. We have Hibernate reactive guides. We have JPA, MongoDB, JDBC, loads. So on the cloud side, we've been hard at work on the cloud modules. So apart from updating the cloud modules to the latest version of the different cloud SDKs, AWS SDK v2, we also added support for AWS Lambda and API Gateway Payload v1 and v2, as well as creating the AWS Lambda CDK definition for deploying serverless applications to Lambda. So we invested a lot there. For Oracle Cloud, we added support for Oracle Cloud Certificate Servers and replaced the transport layer. So the default transport layer for the Oracle Cloud SDK is Jersey, which adds another HTTP client that you don't really want when you've already got Netty. So we replaced the transport layer in the SDK, and also by default the SDK depends on Jackson. We removed it, so you don't need Jackson. You can just use Micronaut serialization, which eliminates serialization and makes everything faster and more efficient. Which brings me to GraalVM Cloud Native. So at Oracle, we have an opinionated build of Micronaut, which is designed primarily to serve a couple of purposes. One is to curate the set of open source modules that Oracle provides support for, as I work at Oracle, and we provide support for a wide range of teams, both internal and external. And Micronaut has many modules, and we can't support everything, so it's a subset. And it's also opinionated project generators, so of how we want basically test and support multi-cloud applications that are deployable to Oracle Cloud, AWS, Azure, GCP, etc. So it's a set of project templates and guides and a lot of testing behind the surface to make sure that everything works with native image, everything is native first. And initially we've launched with AWS and Oracle Cloud support, but we're going to add Azure and GCP because they're supported by Micronaut. And it's like guided tutorials and labs. So it's all of the artifacts part of GraalVM Cloud Native are Micronaut modules, but they're built at Oracle on Oracle hardware detached from the internet, because many Oracle customers have concerns over supply chain attacks. So we've built everything from source. So I think it's designed for a particular audience, and and complementary to the open source work on Micronaut that we are very heavily invested in. But basically, you can go to graal.cloud, if I could, because I'm not connected to the internet. Let's see if I can get an internet connection here. Yeah, if I had I don't have an adapter. Okay. So basically, it's a project generator very much like Micronaut Launch, where you can, it looks like I'm not going to be able to demo it, but basically it creates a multi-project structure where you have the shared library project and one module for OCI with the configuration necessary to deploy to OCI, one module for AWS with the configuration necessary to deploy to AWS, and you basically think at a service level. So I want to use secrets, or I want to use database, or I want to use parameter store, and it'll automatically configure those services so that you don't have to do anything. You can do multi-cloud deployments, deploy some to Oracle Cloud, some to AWS, and just be and be truly multi-cloud. So we have benefited a lot the Micronaut community. Oracle's investment in Micronaut is massive. We have like 15 people at Oracle roughly working on Micronaut, and integrating it. Internal, external users is heavily adopted. And this cloud first focus has meant that we have built and tested and invested heavily in integration with object storage, logging, metrics, tracing, everything that to build modern cloud applications. And the goal is to make sure that the application is portable across, so you can deploy it to whatever cloud without binding to the cloud-specific API. Okay, so we're 5 minutes left. Where to learn more? You got the Micronaut documentation. You got the Micronaut guides. We have the guides infrastructure in Micronaut is incredible. The day after a release, we bump the version. It runs all the tests. All the guides are tested, and updated, and run and refreshed automatically. And it's actually a massive test suite. The guides. Every guide is not just content; it's also a test suite. And there's tutorials on loads of things. The Graal Cloud native guides I want to point out as well, because they're cloud focused, but also they provide virtual labs. So you can go in and start like a virtual lab where you get like a virtual IDE. So you don't even you need a local environment, and you can test deploying to the cloud and so forth. The GraalVM documentation, and do follow us on social. So what's coming? In Micronaut 4.2, we're going to add source generation APIs for the compiler, with potential long-term to do more around source generation rather than bytecode generation, for what we do now. We will be adding Micronaut observability support, ASCII documentation generation from the OpenAPI. So the OpenAPI features that we just showed you, you'll be able to generate ASCII documentation, which you can turn into PDFs and web pages to document your REST API, which is going to be really cool. Even more performance optimizations, and obviously adding JDK21 to the launcher, and updating to Gradle 8.4, which will support JDK21 officially. So yeah, in summary, the future is intelligent compilers, small and linear runtimes. Just want to reiterate that. And I think Micronaut provides an excellent set of building blocks for building modern applications. It provides a lot of performance, a good balance between performance and productivity. We didn't just focus on one. We tried to do the whole story. And Micronaut 4 brings a lot of improvements to the developer experience. And the native integration with GraalVM is getting better and better. Thank you very much. Does anybody have questions? Q&A time. Yeah?
In your projection example, could you have used the author name from the association class in the projection directly?
So in the next version of Micronaut data that we're working on now, you'll be able to do that. It's coming out soon, where you can join, get the association, and also do a projection across. So that's something we have on our roadmap. It's coming soon.
Does it generate
The correct query, yeah. Yeah, we're ready. I think it's the most important feature of Micronaut data, JDBC. It's a very different approach to. You see so many applications that use Hibernate, and it's like just get everything, right? All the data, all the associations, and we're trying to focus on like people building efficient applications, and fetching just the subset of the data that you need is really, really important. In reactive, it's even more typical because lazy loading is a blocking operation, right? So you literally have to do that in that manner, right? A lot of people regard lazy loading in Hibernate as a bug. That should never have been there. It's a debate that could be had, right? Yeah? Any focus on what, sorry? GraphQL. So the question is there any focus on GraphQL? We updated the GraphQL module to support Micronaut 4, so the existing GraphQL module works with Micronaut 4. But we are aware that like it's the developer experience we would like to improve to make it even more tightly integrated. So it's something we'll be looking at the next year probably. Actually, Graph is going to be a theme for next year for us because we're also missing Graph database support. So next year we want to invest in graph databases and supporting different graph databases. And you know, even Oracle database has graph features nowadays. So we supporting graph use cases in Micronaut data just makes sense. Apart from GraphQL. Okay, well, thank you very much, and I hope you enjoyed the presentation.